Stop right here. This is not one image. This is 4 different views of the same object, and they do not agree with each other. Same target, same time window, different materials. And that's the problem. Because if everything around 3i Atlas were behaving normally, these panels would look similar. They don't. And once you see why, you can't unsee it.
NASA SPHEREx didn't just look at 3i Atlas. It separated what's around it by what it's made of. Dust, water, organics, carbon dioxide, and each one tells a different story. Let's go through them one by one. Let's start with dust, because this is the baseline. This is the component we understand the best. What you're seeing here is a broad, asymmetric cloud centered on 3i Atlas, with material clearly spread outward rather than tightly confined. That shape matters. Dust grains are strongly affected by sunlight. Once they're released, radiation pressure pushes them away from the source, stretching the cloud and smearing out fine structure. And that's exactly what we see. The dust distribution is wide, diffuse, and directionally biased. It's not locked to the center. It's already decoupled. This tells us something important right away. Dust is not tracing the same physical process as everything else. In other words, once dust is released, it quickly becomes a passenger of the environment, not a marker of where activity is actually happening. So if all materials around 3i Atlas were behaving the same way, the other panels would look like this one. They don't. And that's where the story starts to diverge.
Now look at the water, and immediately the behavior changes. Unlike dust, the water signal is far more compact. It stays close to the center with a much tighter, brighter core. That tells us water isn't just being swept away after release. It's tracing something closer to where activity is actually happening. Water molecules don't respond to sunlight the same way dust grains do. They expand outward as gas, but they remain more tightly coupled to the source, at least initially. And that's exactly what this map shows. A dense central region surrounded by a softer halo, not a broad smear. This is important because it means water is giving us a cleaner view of the inner environment around 3i Atlas. In other words, if dust shows us what gets pushed away, water shows us what stays anchored longer. Already, we're no longer looking at a single uniform process.
Now we get to the organics, and this is where the symmetry really breaks. Unlike dust or water, the organic compounds don't form a smooth cloud. They appear patchy, clumped, unevenly distributed. You're not seeing a single continuous release here. You're seeing multiple localized regions contributing material at different strengths. That tells us the source of these organics is not uniform. Whatever is producing them isn't spread evenly across the environment. Some regions are active, others are quiet. And that matters because organic molecules are more fragile. They break down faster under sunlight and they don't survive long once they drift too far from where they're released. So when you see them clustered like this, it means you're looking close to where they originate. In other words, this map isn't showing flow, it's showing structure. By now, the pattern is clear. Dust spreads, water stays tighter, organics fragment into pockets, and that leaves one last panel, the one that behaves differently from all the rest. And finally, carbon dioxide. This is the panel that ties everything together. Unlike dust, CO2 doesn't spread far. Unlike organics, it doesn't fragment into patches. And unlike water, it remains tightly confined. What you're seeing here is a dense, nearly symmetric concentration centered on 3i Atlas. That symmetry matters. It tells us this material is staying very close to its source. Carbon dioxide sublimates differently. It can be released at lower temperatures, and it doesn't get pushed around as aggressively once it's out. So when CO2 stays this compact, it's acting like a tracer of the deepest activity region. In other words, if dust shows us what gets carried away and water shows us where activity begins, carbon dioxide shows us where that activity is most tightly anchored. 4 panels, 4 materials, 4 completely different spatial behaviors. This isn't a single cloud. It's a layered environment. And once you see that layering, the recent brightening of 3i Atlas starts to make a lot more sense. Because whatever's driving that change isn't happening everywhere at once. It's happening in stages. So now the question isn't whether 3i Atlas changed. It clearly did. The real question is why different materials are responding so differently at the same time. Is this layered behavior telling us something about how activity is turning on or about where it's coming from? That's the part we still don't have an answer to. If you've been following this object from the start, let me know what you think is driving the shift. I read the comments and I'll update you as soon as the next data drops. Before we end, quick disclosure. I use AdGuard VPN to block trackers and add an extra layer of privacy online, especially when I'm researching or browsing. If you decide to check it out, there's an affiliate link in the description that supports the channel at no extra cost. Thanks for watching. Stay curious, and I'll see you in the next update.